Hi everyone, I'm Sonoma, and today I'm going to tell you about the universal testing machine and how we use it at the UC Botanical Gardens for the Macrosystems Ecology Lab. There are three main tests that we do with this testing machine, being the bending, punching, and shearing tests. So here you can see me setting up the bending test using an Allen wrench to adjust the avils on the base of the machine where the leaf will be staged and ready to be bent. Next, we collect the actual leaf samples. This was a bucket of leaves that we already collected from the UC Botanical Gardens earlier in the day, and the key is finding one that's nice and hydrated so that it's ready to be used on the machine. We then turn the wheels so that the load cell, or what's moving now, gets as close to the leaf as possible without touching it. The point of this load cell is to measure the force that we exert on the leaf and convert it into an electrical signal. So how does it work? Essentially, there's a spring inside of this system that when compressed will convert that force into voltage, and then that voltage will be translated into a force value that will be displayed on the white device in the top part of the screen, and also recorded on the left-hand side computer. Note also that the computer is graphing the force applied over time. The computer on the right side, which isn't pictured now, but will be shown later, is also graphing in real time. However, that is documenting the travel or displacement over time. It's around this point in time when we can stop turning the wheel, since it looks like on the left side graph the force has reached its maximum. And at this point we can also check the other graph to make sure that it's relatively linear, since it's measuring the displacement over time, and that rate should be fairly constant. Now we can use calipers to measure the thickness of the whole leaf, as well as the width of the whole leaf, and document it on the sheet below. And keep in mind that this procedure will be repeated for only half the leaf as well. Next, we'll move on to the punching test, which requires switching out the grips and fixtures that we used previously for the bending test for a stage that's more suited for both the punching and the shearing tests that we'll do later on. Once that's secure, the second and final step of setup is switching out the white digital force gauge for one that can be used with the punching and shearing accessories. Just as we did before, we're going to use a hydrated leaf sample, but this time we're going to sandwich it between the two plates shown below so that the leaf sits in place and doesn't move while we conduct the punching test. For this test, we'll be punching the leaf 4 times, and this next step is a little challenging since the first 2 punches will be aimed at puncturing through the midrib or the main middle vein of the leaf. It will be easier to align the punch needle for the other 2 punches, since we'll be aiming for the lamina for those, which is the more fleshy, leafy part on either side of the midrib. For this test, the graph of force over time will look a little bit different from the bending test, and that will have one really sharp peak right after it punctures through the whole leaf. And that's when you know it's time to turn the wheel back, raise the needle, and look at whether or not you fully punctured the part of the leaf that you were intending to, which in this case was the midrib. And for this test, we'll be using the calipers only to take one measurement, which will be the thickness of the leaf at the point it was punctured. And And finally, we have the shearing test, where we'll change out the punching needle for the shearing blade and also change out the plates that we used from before so that instead of a circular hole that will allow us to punch through, now we have a linear one that will allow us to cut through the leaf. Once everything's secured and aligned, we can take another leaf and sandwich it again between the plates, screwing it in place. The goal here is to cut all the way through the lamina on one side until you cut through the midrib as well. And with the calipers, we're going to measure the thickness of the midrib and its width. Then do the same for the lamina, measuring the thickness and the width of the portion that was cut. And for the force graph, we expect to see a sharp peak when we cut through the tough midrib. Taking these measurements together, we can investigate many mechanical and structural leaf traits. For example, the UTM helps us better understand variation in leaf stiffness using the bending test, or evaluate the effects of simulated herbivory using the punching and the shearing tests. So thank you for joining me for a brief overview of this machine, a great tool for researching all that leaves can do behind the scenes. See you next time!